In this video, we will be solving some problems on molarity. This is the third video in series of molarity and molality. The first one was on the concepts of molarity and molality. The second one, I have solved some problems on molarity. The links to those two videos will be in the description. If you haven't checked that out already, I really encourage you to do that. So the first question here says that, what is the molarity of a solution which contains 18 grams of glucose in 250 grams of water? We know that molality, the abbreviation for molality is small m, is equals to moles of solute divided by mass of solvent. So what they have given us is 18 grams of glucose. So first of all, we'll have to convert that into moles. And secondly, they have given 250 grams of water. We need to convert 250 grams into kilograms. We need kilograms in the denominator. So you can proceed by first converting 18 grams into moles and then 250 grams into kilogram and then divide it as we had done in previous videos, or we can use a shortcut formula for molarity. Now this formula is almost same as the shortcut formula I had given in molarity. Only thing, there will be one slight difference and I'll tell you that. Now here again we need weight of solute into 1000 divided by the molar mass into weight of solvent. So how this formula works again is that weight of solute upon molar mass will give you number of moles of solute in the numerator. 1000 divided by weight of solvent, this part will give you weight of solvent in kilogram in the denominator. So it is again moles divided by kilogram. That's exactly what it is. But the difference here from molarity formula is that there we use volume of the solution. Here we are using weight of the solvent. So that is one big difference. Again, I'd like to remind you all that this formula works for everything except if the data is already given in terms of moles and kilograms. If they are given already in terms of moles and kilogram, you directly divide them. You do not have to use this formula. Let me use this formula and solve it. Now they have given us the weight of the solute and also the weight of the solvent. We need to find the molar mass of glucose. So glucose is nothing but C6, H12 and O6. So the molecular mass of glucose is 6 into 12. There are 6 atoms of carbon and weight of each atom is 12. Plus 12 into 1, that will be 12. Plus 6 into 16. 6 atoms of oxygen and atomic mass of each atom is 16. So when you simplify it further, you get the molar mass of glucose as 180 grams. So 1 mole of glucose will weigh 180 grams. Now when we have found the molar mass of the given solute, let us input all the data into this formula. So firstly, weight of solute they have given us is 18 grams and the weight of solvent they have given is 250 grams. So weight of solute is equals to 18 into 1000 divided by molar mass. We just found the molar mass to be 180 into weight of solvent, that is 250 milliliters. So 250 ones are 250 fours are 18 ones are 18 tens are. So the molality is 4 by 10, or which is equals to 0.4 molar, small m. The second example reads, a sulfuric acid solution containing 571.4 grams of sulfuric acid per liter of solution has a density of 1.329 grams per centimeter cube. Calculate the molarity of the solution. So they have given us the mass of the solute. Solute is sulfuric acid here. The mass of solute is 571.4 grams. They have said that there are 571.4 grams of sulfuric acid per liter of the solution. So using this data, if we find the number of moles of sulfuric acid in 571.4 grams, then we can find the molarity, because molarity is nothing but those many moles of the solute per liter of the solution. Molarity we can just find by finding the number of moles in 571.4 grams of sulfuric acid. But we do not need molarity, we need to calculate molarity. So how we are going to proceed is that, first of all, here we are going to find how many moles of sulfuric acid are there in 571.4 grams of sample. So the molar mass of sulfuric acid is, there are 2 atoms of hydrogen and each atom will weigh 1, so it will be 2, plus the atomic mass of sulfur is 32, and there is only 1 atom, and there are 4 atoms of oxygen and mass of each atom is 16. So when we add it, we get 98. So the molar mass of sulfuric acid is 98. They have given us a sample of 571.4 grams. We need it in terms of moles, so we'll keep mole in the numerator, and 1 mole will weigh 98. So number of moles in this given sample is 571.4 divided by 98, which is equal to 5.83 moles. 5.83 moles. Now, since in the question they have given these many moles are there in 1 liter, we can consider 5.83 itself as the molarity of the solution. We need to find molality, so let's proceed further. They have given that the density of the solution is 1.329. Density is equals to mass divided by volume. So we need to find the mass of the solution. So mass will be density into volume. They have given us the density as 1.329 grams per centimeter cube, and the volume they have given as per liter. So 1 liter will have 1000 centimeter cube. So the centimeter cube units will get cancelled. Mass of the solution is equals to 1.329 grams into 1000, which is equals to 1329 grams. We do not need it in grams, we need it in kilograms. So you multiply by into 10 raised to minus 3. So that is equal to 1.329 kilograms. Now remember, this value, this mass is the mass of the solution. But in the formula, we require mass of solvent. So what we do is, we take the mass of solution and we subtract the mass of the solute. So what we will get is the mass of the solvent. So now the mass of the solvent will be equal to 1.329 kilogram minus, we see that it is in grams here, 571.4 grams of sulfuric acid is there. So we convert it into kilograms, and what we get is 0.5714 kilograms. So 1.329 minus 0.5714, which is equals to 0.7576. So we'll round it up, 0.758. 0.758. So now we have all the data required. We have the number of moles of the solute, and we have the mass of the solvent. This is in kilograms. So when we divide these two values, what we get is the final molality of the solution. So molality of the solution will be equal to 5.83 moles. This is the moles of solute divided by 0.758 kilogram. This is the mass of solvent, moles. So when we divide these two, we get 5.83 divided by 0.758, which is equal to 7.69. 7.69 is the molality of the given solution. Let us take a last question. Calculate the molality of 15 molar hydrochloric acid solution with a density of 1.0745 grams per centimeter cube. So they have given us the molarity of the solution, and what molarity means is that number of moles per liter. So there are 15 moles of hydrochloric acid in 1 liter of solution. So let us begin. Now number of moles of the solute is 15 moles. Volume of the solution is equals to 1 liter. Now they have given us the density as 1.0745 grams per centimeter cube. Density is equals to mass upon volume. Mass is equals to density into volume. Density is 1.0745 grams per centimeter cube into 1 liter. 1 liter, we need it in centimeter cube so that it cancels each other out. So 1 liter will have 1000 centimeter cubes. So these cancel each other out. What we get is the mass of the solution is equals to 1074.5 grams. But to calculate molarity, we know that it should be in kilograms, so it will be 1074.5 grams into 10 raised to minus 3. So that will be equal to 1.074 kilograms. Now we have the mass of the solution, but we need to calculate the mass of the solvent in order to calculate the molality. So let us proceed in doing that. How can we do that? Here we have the mass of the solution. So if we minus or cancel out the mass of the solvent, that is mass of 15 moles of hydrochloric acid, then what we get is the mass of the solvent itself. We first find the molar mass of hydrochloric acid. So there is 1 atom of hydrogen and mass of 1 atom is 1, and there is 1 atom of chlorine and mass of 1 atom is 35.5. So the molar mass of hydrochloric acid is 36.5 grams. So what it means is 1 mole of hydrochloric acid will weigh 36.5 grams. But we have 15 moles. What we do is we multiply this by 15. So what we get is 36.5 multiplied by 15, which is equal to 547.5. 547.5 grams of hydrochloric acid is there in 1.074 kilograms of this solution. Here it is in grams, here it is in kilograms. It won't work out. We want to convert grams into kilograms, so it will be simply into 10 raised to minus 3 or 0.547 kilograms. So now to find the mass of the solvent, it is equal to the mass of the solution, which is 1.074, minus the mass of the solvent, which is equal to 0.5475, which is equal to 0.5265, 0.526. So this is the mass of the solvent. So now the molality is equals to number of moles of solute. We have it as 15 moles. Mass of the solvent is 0.526 kilogram. 15 divided by 0.526, sorry, 526, which is equals to 28.517. It's equal to 28.52 molar. So 1 kilogram of the solvent will have 28.52 moles of hydrochloric acid.